Lecture Newton's laws of motion, video number 5. See students, in this video what I am going to explain you about the Newton's second law of motion. About the Newton's second law of motion. According to this Newton's second law of motion, which is in fact a real law, you all know already, there are some students who are very much aware of all these concepts, but I am just giving you a simple revision to you all people. And in this Newton's second law of motion, what I am going to explain, some unique things if I am able to create. Let us see. What is that? It states that the rate of change of momentum. The rate of change of momentum is directly proportional to the force impressed. F is directly proportional to ddt of P. Or F is equal to K times ddt of P. What is P? That is mass into velocity. So F is equal to what? Km ddt of V. What do you find? F is equal to Km into A. What is A here? The acceleration. What is A here? The acceleration. What is F here? The force impressed. Now, you'll put a question. Why do we introduce K? Well, K is the constant of proportionality. K is the constant of proportionality, and it tells us about the strength of the relation. Suppose we have two forces or two momenta. See, if we have ddt of P1 plus ddt of P2, then would you find the force is F. Students, what is the net force? I have just told the net force is what? 0. So ddt of P1 plus ddt of P2 equal to 0. When the net force is 0, means F1 plus F2 is equal to 0, which is Newton's third law. Which is Newton's third law. It means that the second law is giving us the Newton's third law, because F1 is equal to minus of F2. This is Newton's third law I had given you. You may put one question, students. What do you say about the third law? It tells that forces coexist in pair. This is action, then this is reaction. If F2 is positive, then F1 is negative. Means action and reaction, they coexist in pairs. Action and reactions, they coexist in pairs. And students, what is the second law states? F is proportional to ddt of P. F is proportional to ddt of P. Correct? and F is equal to K times ddt of P. Well, P is what? Quantity of motion contained in a body. That is mass into velocity. Then F is equal to what? Km ddt of P. What is ddt of V? That is acceleration. So, second law states what? The rate of change of momentum is directly proportional to the force impressed. And if I take the two momenta P1 plus P2 equal to F, if I take net force 0, then ddt of P1 is what? F1. ddt of P2 is what? F2. F1 is equal to minus of F2 and F2 is equal to minus of F1. What does it mean? If F1 is action, F2 is reaction. If F1 is action, F2 is reaction. If F2 is action, F1 is reaction. So action and reaction, they are equal and opposite. Simple it is. So it means there is no force which is an action and there is no force, this is an reaction. They coexist in pair and the net force is what? 0. Strictly, students, the force what we talk about in the Newton, it is applicable only for the point masses, not for the macroscopic. Whatever we talk, the whole mass M. One thing more, it is a misconception that whenever there is a force acting, it is mass into acceleration. Always no. Sometimes velocity is constant, mass is changing. So it is the momentum, it is the rate of change of momentum which changes and causes force. Force is not caused by only the mass into acceleration. It is always possible when mass is constant, but force is there whenever there is a rate of change of momentum. So what is the significance of the Newton's second law? To destroy the natural state of a body, we need an external agency that is called force. To destroy the natural state of the body, we need an external agency that is called force. And students, third law significance, forces coexist in pair. Hope these basic topics must be clear to you, and please put your comments in the comment box and I will be planning the further lectures. Thank you very much.